Mesdames, Messieurs, Señores y Señoras, ladies and gentlemen, welcome to Paris. Welcome to Pasqal Thoughts 2026. We're really delighted to have you here in this room for the second edition of this event, who brings together quantum pioneers, industry leaders, researchers, and innovators to explore how quantum computing is shaping the future. We have 15 countries represented here today. I know many of you came from very far, so on behalf of the whole Pasqal team, I'd like to thank you all very much for being here, and that deserves a round of applause, please. And today, ladies and gentlemen, is not any day. It's April 14th. Any of you know what is the specific date? Maybe we're not doing this event. Maybe it's not a coincidence if we're doing this event today on April 14th, because it's World Quantum Day, exactly. And do you know why we celebrate it on April 14th? It's because of my friend Planck, the physicist. His constant is 4.14 times 10 to the negative minus 15, something like that. It's 4.14, so that stands for 14th of April. That's the reason why we do World Quantum Day every year on April 14th. So ladies and gentlemen, happy World Quantum Day, everyone. So let me just shortly introduce myself, as I haven't done it yet. I'm not an expert in quantum, I'm sorry, despite being here for the second time. So my name is Marco Oranier, and I'm a host and presenter, and glad to be your master of ceremonies today on this special gathering. Jokes aside, we stand at a pivotal moment. AI, high-performance computing, and quantum are converging and reshaping what computation can achieve. Quantum is moving from the lab into industry. Research and real-world needs are now feeding each other, and early adopters are already developing concrete use cases on real hardware. Pasqal is at the center of this transition with their full-stack neutral atom quantum computers and a growing ecosystem of partners and customers. Today's program will take you through 4 core themes: the synergy between quantum, AI, and HPC, high-performance computing, the path from science to technological impact, building the global quantum ecosystem, and of course, Pasqal's strategic vision for the road ahead. To bring this to life, we have an exciting program and lineup. You'll hear from Pasqal's leadership, of course, leading scientists, industry players, European HPC centers, financial institutions, and ecosystem pioneers. So please make yourself comfortable, not too much. I know you just have lunch, so I hope you're not too comfortable, but this is a very nice, looks like we're in a cinema here today. So we wish you a really rich and inspiring afternoon. Without further ado, ladies and gentlemen, to open the day and share Pasqal's broader vision for this new era of computing, please join me in welcoming Pasqal CEO Wasiq Bokhari.
Bonjour. Hello. Welcome. Bienvenue. It is great to be here, and thank you for being here. We have so many friends, investors, partners, customers here. It is such a delight. And we have a very exciting program and set of topics to go through today. So my job right now is to set the stage for the rest of the day and to share a bit of the vision for what Pasqal is and where we are headed. So my talk overall is broken into 3 parts: past, present, and future. So let's start with history a bit. You know, this area that we are sitting in, it's in the heart of a part of Paris which is called Nouvelle Athènes, New Athens. This was the home of people like Chopin, Delacroix, Monet, Hugo, Dumas, George Sand. So we have this really deep tradition of excellence. And all of these people were innovators and risk takers of their time. And with this deep tradition of excellence in France that we build on, and these deep roots allow us to not only connect to the past, but to build for the future, to imagine the future, to build the future of computation. So in a sense, just think about it. The spirit of these people is here in this room with us. And I hope that today is a very energizing conversation and illuminating conversation for all of us as we talk about collectively the future of computation. So talking about history, Pasqal has a history as well. By the way, we just turned 7 years old. Happy birthday, Pasqal. So our history starts with the seminal work that was done by one of our co-founders, Alain Aspect, Nobel laureate. He was the first person who showed the violation of Bell's inequalities. In other words, he started quantum information sciences. And then we have Georges Olivier, who was the first person to trap a neutral atom. And then we have Professor Antoine Bravais, who is the co-inventor of the neutral atoms approach itself and built the basic building blocks that has made neutral atoms such a scalable, promising approach for quantum computing. Talking about more history, do you know this quote from Richard Feynman? Which is, nature isn't classical. Actually, he says, damn it, after that. Nature isn't classical, damn it. If you want to make a simulation of nature, you better make it quantum mechanical. There's actually a second part of this quotation, which goes that it's actually a wonderful problem because it's not easy to solve. And he was true on both accounts. He said this 45 years ago in 1981. And this has been a driving force for the development of quantum computing in the first place. And of course, it's at the heart of what we do. But there's something very profound about this statement. There are two things that are special about quantum computing. One, through quantum computing, we are able to go through a lot of possibilities exponentially faster than we can do through any other form of compute. And the second is, when we have to simulate nature, which at the heart of it is quantum mechanical, then quantum computing is the only way to do it properly. And this has been a challenge that everybody has been trying to address for the longest time. So talking about today, in our last Pasqal Thoughts event, we made 5 statements and 5 commitments. We said we will execute and deliver on our technology roadmap. We said we will deploy our quantum computers in standard data centers. We said we will engage with customers and we will work on building solutions that provide value. We said that we will take the mystery out of quantum computing and build communities. And the last thing was that we will be a global company. I'm very happy to share that we have met each and every one of these commitments and more. So in the present, I'll talk about some of these highlights to set the stage for the rest of the day. Remember the quotation I had for Richard Feynman about simulating matter? Just recently, 2 weeks ago, there was an article that described the work that was done by our team at Pasqal. It showed that for the very first time, we were able to predict and simulate properties of materials and then verify them experimentally. This cannot be done classically. This is an example of quantum advantage for real-world materials. And we have a very exciting session about this later today. But that's not all. There's another very interesting result. We just showed that we can solve differential equations using logical qubits. This again is a first. Why are differential equations important? Because they're the heart of every application, from heat transfer to chemical kinetics. And we'll talk about this as well. Second promise we made, that we will deploy our systems in data centers. We now have 7 operating high complexity QPUs in the world and 3 more in production. Just last year alone, we delivered and deployed 4 QPUs. And all of these quantum computers work in standard data centers without requiring specialized cryogenic systems. That is a big one in terms of adoption. And we have systems operating at Gency, Ulick, Aramco, Chineka, and District. The Aramco one is a very important one because it's the first purely commercial sale of a QPU, essentially for the world's largest energy company, for use for business problems for the mainline business. So quantum computing for us solves business problems today. It's not a thing of the future. The other big thing we did last year was we enabled access to our QPUs through the cloud. Why is that important? Because now instead of buying a machine, you can get access to our state-of-the-art quantum computing, to our application toolkit, our software, and you can do it without significant capex. It reduces the barrier to entry. Very important for adoption. One of the big goals for us has always been, how do we engineer systems that are well engineered and they're reliable, they're scalable, and they operate with high performance in standard HPC environments. So that's a big part of our design, but that's not all we do. We also need to be able to manufacture these systems. And last year, we opened our second manufacturing facility, and now we have two of them, one in France, obviously, and the other one in Canada. And we have this methodology, just like Intel, of copy exact methodology. We were able to show that once our Canada facility was up and running, we were able to manufacture and produce a QPU which met all of our specs. It's a big deal. So I've talked a lot about our hardware side, but let's talk about what happens. So clearly, hardware is a starting point of it. But to enable use, to solve business problems, we need to go above that. Now, we all agree that quantum computation is going to be one part of the future of compute alongside traditional computation and AI-based computation. So with our partners, IBM and NVIDIA, we have built this resource coordination layer, which allows us to seamlessly pass the problems between CPUs, GPUs, and QPUs so that we can solve it effectively for the customer. We are a founding member of NVQ Link initiative with NVIDIA, and with IBM, we have demonstrated Slurm integration, which allows us to be part of the job scheduling and resource allocation at scale, at data center level, either at physical way or virtual way. Above this is the application layer. And the way we think about this is that we allow and we enable all the primitives to build different kinds of applications, from algorithms to other components that are needed. And on top of it, we work with partners to build specific applications in specific verticals. This is a full stack approach. This is a customer-centric approach. This is an approach built to solve problems. So let me recap. What did I share with you? We want to solve real-world problems. So I just talked about that we showed quantum advantage, and we showed solving differential equations in analog and in digital mode on the same hardware. Second, our QPUs operate in standard data centers without cryogenics, with very low power footprint. The power footprint of our latest generation QPU is about 4 kilowatts. It's probably like 2 microwave ovens. It can probably fit in your kitchen as well. So think about that in terms of a scalable, deployable system. Then we built the software stack, which enables the creation of applications. And finally, our technology platform itself is very flexible, so it does not become obsolete, which means that we can deploy and stay deployed with our customers, solve problems, and earn trust with the customers. So why are we doing this? Because for us, the most important thing is to enable practical and useful computing. In the end, our customers, what they need is solution of problems, and compute is a resource. Our job is to deliver a compute resource which stands alongside traditional GPU-based or QPU-based or CPU-based compute and delivers the same sort of performance, reliability, and availability that is expected in an HPC environment. That is how we enable practical, useful quantum computation at scale. So where do we go from here? So we are about 280 people today. We have most of our team here in France, but we have presence in Canada, in US, in Saudi Arabia. And there's a couple of really amazing announcements that we made recently. First, we announced new funding of 340 million euros, about $400 million. I believe this might be one of the biggest fundings of a European company in recent history. This gives us the resources and the ability to go and be who we want to be, to become that global company. And second, we announced that we are going to go public with Black-Schoeder Acquisition Corp. Our friends from Black-Schoeder are here. And with an initial listing on NASDAQ, followed after that with a listing on Euronext Paris. This again is our path to be a global company, to be a dominant player in quantum computing. So let me talk about how we view our path towards practical quantum computing. So when people talk about the future of quantum computing, they usually think about three phases. The first two phases are quantum utility, quantum advantage, that typically goes till 2030. And then there's the fault-tolerant area where you have FTQC, which is 2030 onwards. A lot of companies would probably focus very much on the phase 3, which is FTQC onwards. But let me share something with you. Quantum computing in analog mode is the way nature computes. You know, we are all living, breathing examples of quantum computing because every molecule inside of us is essentially doing a calculation of minimal energy state, and it's finding that through a quantum process. So why can't we use that to do practical quantum computing today? And we do. So our first focus is on the same hardware, run analog quantum computing and solve really important problems. Remember Feynman's quote? Very important problem. Material simulation. Another important problem, optimization problems. These are problems that occur in huge industries. In materials, from catalysis to new materials to pharmaceuticals and so on. In the area of optimization, financial services, logistics, and multiple other large industries. Energy is a very important one. So we will focus on specific verticals using our capabilities which are for practical, scalable quantum computing and bring value to our customers in the analog quantum computing mode. Now we have a big advantage. The same hardware can do FTQC. So in the meantime, we continue working on advancing our FTQC roadmaps, and we will deliver on those roadmaps in the same competitive way with anybody else in the world. So post 2030, we have FTQC offerings that also come out. We feel that when we enter the FTQC regime, the analog regime will not go away because in analog regime, you do not have the overhead of gate operations. So we feel that we will be able to provide value using both modalities, and we are able to. Let's put it all together in terms of what our vision looks like. At the base of it is having reliable enterprise-grade QPUs and manufacturing process that can deliver it. The next step is enable high-value use cases. Beyond that is building a global presence. Scaling quantum computing as a service, which is our cloud access. We just talked about achieving quantum advantage in materials and then going deeper into that. And this allows us to do something very special. Using our quantum computers, we can generate data which can then be coupled with AI or ML models to enable this cycle further. These are all things that are within our purview. So I'm going to end my talk, and I'm going to end it on the following message. Our vision is to bring in a new era of computing so that we can solve problems that matter. We can solve problems that are currently hard or impossible and the problems that matter. Just imagine this. What if one day we believe we'll be able to go through trillions of possibilities in real time? Imagine what that does to optimization problems in logistics and financial services, energy, and so on and so forth. We believe that we will be able to design and tailor any molecule that can exist entirely computationally. And one day we'll be able to do that in a single day. Imagine what that will do to the field of pharmaceuticals, specialty materials and so on, catalysts. All this sounds far-fetched, but remember, technology has an exponential component to it, and that's why we always keep on getting surprised by it, but it always happens. We are on the path to this. This is the magic of computation. What it does is, whatever we can imagine, computation accelerates it and makes it real. And then it changes what we can imagine itself. And that is what has changed the world that we live in today. And we want to do this again using quantum computation. And we are ready. Are you ready to do this? Are you ready to do this together? Let's do it. Thank you.